Now that we know the convective heat transfer coefficients in the inner and outer side of the pipe, we can calculate the overall heat transfer coefficient. So as a recall, we have been expressing before the inner overall heat transfer coefficient, and in this coefficient we find three different terms that corresponds respectively to the inner convection resistance, conductive resistance, and outer convective resistance. So I find here very interesting to calculate first separately each of these terms, because then we can also see what respective weight they have in the overall heat transfer resistance. So now we know all the different values, so we can calculate easily these terms. And so here we can see that so they are all multiplied by 10 at the power minus 3. We have about 9 for the inner, so water side convective resistance, 0.4 for the conductive thermal resistance, and 35.5 for the outer, so the gas side convective heat transfer resistance. So from this, the respective values of these three terms, we can do two conclusions. The first one is that conduction is negligible. Even though we have quite a thick tube, the conductivity inside this metal tube is high enough so that we can completely neglect, if we want, this conductive term. And then a second conclusion we can do is that we have a much higher thermal resistance on the outer side, so the gas side of the system, than on the inner side. So if we want to improve this heat exchanger, we really need to work on the outer side into decreasing this heat transfer resistance on the heat exchange side with the gas and not with the liquid. And so finally, when we do the calculation, we can find 22.04 watts per cubic meter Kelvin. And not surprisingly, the value of the overall heat transfer coefficient is very close to the value of the outer convective heat transfer coefficient, because this is the main term we have inside this overall heat transfer coefficient.